10 years after he invented the special theory of relativity to answer the Michelson-Morley experiment, Einstein was forced to invent a second theory to compensate for what the first one lacked. One of the things it lacked was that it did not deal with objects in acceleration or deceleration, only with objects moving at uniform or unchanging speed. This begs the question how and why the special theory was originally invoked to answer the Michelson-Morley experiment. First, according to classical physics, the movement of the Earth around the Sun is considered an acceleration, not a uniform speed. Yet special relativity claims to deal only with uniform speed. Second, according to Einstein, special relativity is only valid in the absence of gravity. Yet during the Michelson-Morley experiment, the Earth was understood to be in the gravitational attraction of the Sun. Related to this issue is that classical physics regards force as absolute, and thus there is no difference in the gravitational attraction between objects at rest or objects in motion. But special relativity claims there is a difference, since gravity is limited to the speed of light, which difference would be noticed by an observer. Ironically, although the special theory of relativity is often invoked to limit the speed of gravity to the speed of light, the special theory does not include the phenomenon of gravity. In any case, since gravity pervades the universe, the special theory was very limited in its scope, and thus required Einstein to invent a more complete theory of motion, the general theory of relativity. Although it is not our purpose to delve into a thorough examination of the general theory of relativity, we will only make 2 points about the theory that relate to the issue at hand, that is, whether the Earth is in motion. The first point is a rather ironic one. In 1905, Einstein invented the special theory of relativity to answer the 1887 Michelson-Morley experiment and thereby escape the evidence that demonstrated the Earth was motionless in the center of the universe. As noted, since the special theory ignored other facets of celestial movement, such as gravity and inertial forces, Einstein was forced to invent the general theory of relativity. But the general theory, by its foundational assumptions of covariance and coequivalence, permits the Earth to be motionless in the center of the universe. This is admitted by Einstein in one of his more famous quotes. He writes,
"We need not necessarily trace the existence of these centrifugal forces back to an absolute movement of K prime. We can instead, just as well, trace them back to the rotational movement of the distant ponderable masses in relation to K prime, whereby we treat K prime as at rest."
As we can see from the animation, from a geometrical perspective, there is really no difference between the heliocentric and geocentric systems, since all the motions and distances remain the same when one system is converted to the other.
But Einstein added that, from a dynamical or force perspective, there is also no difference between the heliocentric and geocentric systems, especially if the rest of the universe is included in the calculations.
Hence, as we noted earlier, but is worth repeating, the general theory of relativity led Einstein to conclude the following.
The struggle, so violent in the early days of science between the views of Ptolemy and Copernicus, would then be quite meaningless. Either coordinate system could be used with equal justification. The two sentences, "The sun is at rest and the earth moves," or "The sun moves and the earth is at rest," would simply mean two different conventions concerning two different coordinate systems.
Interestingly enough, since the general theory made all motion relative, it was unable to determine which system, the heliocentric or the geocentric, was the actual reality. Not only was the general theory unable to give precise answers to the actual design of the universe, in an ironic twist of fate, it allowed the most crucial postulate of the special theory of relativity to be compromised. In the special theory, the speed of light is limited to 186,000 miles per second in the vacuum of space and could never change. The general theory allowed the speed of light to be any value, since general relativity introduced the idea that light is affected by gravitational and inertial forces present in the pathway of the light. As Einstein himself said in his 1920 book, relativity, the special and the general theory.
In the second place, our result shows that according to the general theory of relativity, the law of the constancy of the velocity of light in vacuo, which constitutes one of the two fundamental assumptions in the special theory of relativity, and to which we have already frequently referred, cannot claim any unlimited validity.
As noted relativist William G.V. Rosser put it,
if gravitational fields are present, the velocities of either material bodies or of light can assume any numerical value, depending on the strength of the gravitational field. If one considers the rotating roundabouts as being at rest, the centrifugal gravitational field assumes enormous values at large distances, and it's consistent with the theory of general relativity for the velocities of distant bodies to exceed 3 times 10 to the 8th meters per second under these conditions.
On May 5, 1920, Einstein gave a speech in Leiden, Holland, titled Ether and the Theory of Relativity. In the speech, he revived the ether for the general theory of relativity that he had eliminated in the special theory of relativity. As Einstein put it, the general theory of relativity required ether, quote, for both the propagation of light and standards of space and time, unquote. His only qualification was that this new ether could not detect motion as opposed to Lorentz's ether, which could. He writes,
recapitulating, we may say that according to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, space without ether is unthinkable, for in such space, there not only would be no propagation of light, but also no possibility for existence for standards of space and time, such as measuring rods and clocks, nor therefore any space-time intervals in the physical sense. But this ether may not be thought of as endowed with the quality characteristic of ponderable media, as consisting of parts which may be tracked through time. The idea of motion may not be applied to it.
Hence, the special and general theories of relativity suffer from internal contradictions, and that is because they are both based on a fundamental error, that the Earth moves. It was only a matter of time before the errors of each theory were exposed. Unfortunately for the rest of the world, the more Einstein's errors were exposed, the more the press and academia sought to cover them up. And the cover-up is the very reason Einstein remains as the hero of modern science today. The cover-up was seen no better than when Einstein's theories were called upon to interpret the 1925 Michelson-Gale experiment, the experiment that demonstrated a daily rotation between the Earth and space.
As the story goes, Ludwig Silberstein, a close friend of Einstein's, had encouraged Michelson to do the experiment. Prior to the experiment, Silberstein had written a paper in July 1921 titled The Propagation of Light in Rotating Systems, claiming that if Michelson-Gale were to show a full ether drift, the result could be answered by general relativity. But this claim set off another set of contradictions. First, Silberstein failed to acknowledge that if Michelson were to show a full ether drift, this would immediately falsify Einstein's theory of special relativity, since special relativity claimed that ether did not exist. Second, Silberstein's claim contradicted what Einstein stated about ether in his 1920 Leiden paper noted earlier. In that paper, Einstein insisted that the ether of general relativity was, quote, not ponderable, unquote. That is, it has no measurable presence. It has no mass and cannot be weighed. It has no concrete dimensions. It has no parts that can be dissected. And it has no time for us to say that it changed or moved from here to there. We cannot detect it because, in the dimensions we live in, Einstein's ether doesn't exist. But that was not the way the ether was being treated by Silberstein and other general relativists to answer the Michelson-Gale experiment. Michelson measured a ponderable ether, but general relativity only deals with imponderable ether. The contradiction is also seen in the write-up of the Michelson experiment by the New York Times of January 9, 1925. On the one hand, its headline admits, quote, "Ether drift is confirmed," unquote, since a full ether drift demonstrating a full daily rotation between Earth and space was measured by Michelson. On the other hand, the New York Times article does not admit that since ether was measured by Michelson, this means the ether is ponderable, the very opposite claimed by Einstein. Einstein stated that his ether cannot be tracked by time, but a tracking of time is precisely what Michelson-Gale demonstrated by means of the ether, since it made one light beam return in a shorter time than the other, which the article itself admits when it says,
"The register in the flight of these beams was an instrument known as the interferometer, which Professor Michelson has been perfecting for 40 years. Through it was visible a white circle, striped with vertical fine lines like hair, drawn tightly across the face of an oval mirror. These were called interference fringes, due to the fact that if the beams reached home at different times, it would be recorded by a displacement of these lines. This displacement was shown in the experiment."
Ironically, instead of admitting that Michelson's 1925 experiment disproved both special and general relativity, the article's top headline is, quote, "Michelson proves Einstein theory," unquote.